Hello, I am Professor Bodziak, and I will be your teacher today. The topic is coding. Okay, so I'm going to give you a small assignment right now, which you will do after my talk is over. Okay, my talk will be about the C program, okay, the language C, okay, and so your assignment will be to write a small C program that prints your name to the screen. Write this on a piece of paper, take a picture of this which shows the paper and you, and then I will send you a message in your app where I will describe how to get that picture to me. Okay, so that will be your assignment for this talk. Now, in this lecture, I'm going to discuss the language C. Okay, I was a software engineer for a long time, and I used C quite a bit. C is one of the earlier languages that you learn in my experience as becoming a software engineer. It's one of the early languages in this, and it was very important because early operating systems were written in C. If you were familiar with the Unix operating system, and then evolving from there was the Linux operating system involved from Unix. Those operating systems were actually written in C. Okay? The programs run on those systems were also written in C. So C was termed a programming language because compilers and operating systems were written in C. So, evolving since the days of C and the introduction of Unix were some other languages. They evolved from C. Okay, more commonly used in more modern time. C++, Java, they're very similar to C. They evolved from the language of C. Okay, so a program is written in English. All right, so the C programming language, like any other coding language, is written in English because human beings write this code. Okay? After you've written the program, you run another program which is called a compiler. The compiler converts this code that you've written in English into machine code, which is the language that's run by your computer. Okay, so on your computing device is a small chip called a microprocessor. This microprocessor is basically the brain of your computer, and when you write a program in a language which is English, or an English program basically, in the language C, for example, it gets converted into machine code after you compile it. Okay, so the program has to be written, and then it's compiled, and then in your program there are calls to what are called functions. So part of the program calls previously written code called functions. These functions are contained in large groups of code called libraries. Now, these libraries must get loaded along with your compiled program, and then you can now execute your program. Okay, so we start off, so those are the basics. Programs have to be written, compiled, executed. So they're written, they're compiled, then they get loaded into the memory of the computer, and then they're executed. Okay, so they must take place in these series of stages. So my first example is going to be a very short program in C, which is a classic a classic printing out onto the screen, which you will use to do the assignment that I gave you. Okay, it's going to print "Hello World" onto the screen. So here is the program. So, you create this program in a text editor.
You have to move it down.
This program must first be created in a text editor. Okay, so this text editor must be used to give this file that this is saved in an extension of a .c. For example, you could call it hello.c. Alright, so you have created this. Now you must compile it. So in Unix, the compile statement is done like this. cc hello.c. So, and as I mentioned, when you compile it, you are translating it into machine code. It's a language that's readable. It's a language that's readable by a microprocessor, which is the brain of your computer. Okay? So, when it compiles it, it creates a file called a.out. A.out is an executable file. So executable means it's runnable, it's going to run. Okay? All you've got to do is type a.out at the command line prompt. So it would look something like this. There's a command line prompt. Type in a.out, and then you hit the enter key. Okay, so this will now execute, and the result will be it will print "Hello World" out to the screen. Okay, so programs consist of functions and variables. I will define a function in this. This applies to the language C, and for that matter to all programming languages. A function is made of statements that describe operations. Programs also have variables in them. Variables store values. Now, in the language C, every program has a function called main, which, as you can see, I've used here. See, that's where execution begins in the language C. Okay? Now, let's look at the program that I've written line by line. Include stdio.h. STD stands for standard I/O. It is a library of input and output files that is basically the code that permits the microprocessor to input and output information. So this line of code says the compiler will include the standard I/O library. Okay. The standard I/O library is where this printf statement is saved. So you can use this in your program because it's saved in this standard I/O library. So include standard IO.h will include information about the standard I/O library. Next is the main function called. And as I described, every program in C begins with its execution at main. Main is a function, right? And every C program must have a main. After every function are parentheses, and within these parentheses are arguments. These parentheses are empty, so in this program there are no arguments going into main. We will see cases where there are arguments that are going to be used. The first case that would come to mind is this printf statement. All right, it's taking arguments within these parentheses, and you can see the hello world \n is arguments within the parentheses of this call to printf. So main in this case will have no arguments, so the parentheses have nothing in them. So we define the main function taking no arguments. It's empty in between the parentheses. The statements of main are enclosed in braces. So here are the two braces. They make up everything that composes the function main. So all functions in the language C are contained within left and right braces. Here, printf hello world \n. Main calls the library function printf to print this line. So it's printing exactly what's in these double quotes. It's printing hello, world. Now, this / means an invisible character in C is going to be printed. Okay, this is the way that the language C prints invisible characters. It's how we show it that there's a character that's going to need to be printed. \n is the new line character. So the new line character means the cursor is going to go down to the next line and to the beginning of that line. So it moves the cursor to the beginning of a new line. So this will print hello world and then go down to a new line. As I described, the statements of all functions, including the main function, are enclosed within brackets. The function is called by its name and then a list of arguments within the parentheses. In this case, hello world within double quotes is called a character string. And \n is the new line character, as I described, that makes the cursor, when this is executed, go to the next line and to the beginning of that next line. Now there's another way we could have written this same program, and I will write it. Now here, I've written the program in a different way. 3 calls to the printf statement. It will produce the same output as this way that I've written it. Okay, so again, I'm including the standard I/O library. It's got a main function call with no parameters. Also they can be called arguments or parameters. And now I'm using 3 printf statements. Okay, so I'm printing first hello. So when executed, it will print the word hello, and then there's a space there. It will print space, world, and then it will separately print the \n, which is the new line character. So that prints out hello, the same as I just did before. It prints out hello world, and then the cursor goes down to the beginning of the next line. Now, I've shown here \n is an escape sequence. Okay? The backslash means there's an invisible character about to be created. Okay? So this permits invisible characters to be typed. Here are more invisible characters that are recognized by C. \T will make the cursor print a tab onto the screen. So a tab is just like 5 spaces together. \B will make the cursor go a backspace in the screen. So whatever it last ended up on, it will go back a space. If you want to print a double quote onto the screen, you type \double quote. And you can put 2 backslashes if you want to print the backslash itself. So basically the backslash is a clue that C is about to print out an invisible character. Okay, so that is slightly altered when you put a double quote after it. In this case, the double quote will be printed. Or if you put a backslash after it, in this case, the backslash will be printed. Okay, so that's something very particular about this language. And now I will discuss another program. This one is going to be a bit longer. Okay. This is going to print a table which consists of a series of values which are temperatures in Fahrenheit, and they're getting converted into Celsius temperatures in the next column of the table. So it's going to print a series of temperatures ranging in 20-degree increments from 0 to 300. And we will discuss further. Things within a slash and a star are considered to be comments. So the compiler ignores comments. So I've described what this function is doing by putting my description between the slash, the star, and the star and the slash. So that this right here is a comment. And we'll discuss more further the nature of comments. So this is going to print that table. All right. All text written between the backslash star and the star backsplash are comments. They are used to explain the program and are ignored by the compiler. They can appear anywhere in the program. So now if you were to forget this, to put in this backslash and star, the compiler would give you errors, and it would show you that on that line there were errors and it would not properly compile. Okay. All variables must be declared before they can be used. So a variable is basically a series of characters that are being used to store something that can change. In this case, I'm using integer variables. So this series of characters called var is going to be used to store an integer which is subject to change. And it's going to store an integer called Celsius, which is subject to change. So all variables must be declared before they can be used. Usually you declare them at the beginning of a function so that you can use them at the rest of that function. So here these two are the declarations that I used: integer var Celsius and integer lower upper step. Okay, each line is concluded with a semicolon. In C, that means that you've reached the end of the line. Okay. Now, these are integers. The range of these numbers of an integer depends on which machine you're running it on. If you're running a 16-bit machine, which you can determine, you can go into the control panel on your computer, And then you can look into like system security, and you can determine what microprocessor your computer is running on, and then you could look up how long. It's called a word in microprocessors. Call it a word. How long is a word in this microprocessor's language? So if it was a 16-bit machine, then you could write numbers that are 16 bits contained within 16 bits. Okay, and a bit is a 1 or a 0. So it's binary arithmetic basically, which is another topic in itself. All right. So with 16 bits, you can write numbers that come between, and I'll write this one out, minus 32, 768, and plus 32, 767. So in a 16-bit integers go within this range. Now these are integers, okay? So the range of these numbers depends upon the machine that you use, as I've described. There's another data type called float, which are floating point data types. Floating point data types are typically 32 bits. wide. They have at least 6 significant figures. So your project for me would be to write a C program that would print your name to the screen. And now, this program right here is the very big helpful clue to get you there. Okay, so you're going to need most of what's in this program because it's going to include the standard I/O library. It's got to have a main call. It's got to have a start and an end bracket on it. And it's got to have a printf statement which prints its arguments to the screen. So this introductory program printed hello world, and it took the cursor to the first character of the next line with the \n. Basically your C program would just have your name here taking the place of hello world. So that is a program that if properly compiled, linked and loaded, and it would run and print your name out onto the screen. So that was the program that I wanted you to write as the project.
Now you got a question for them, for the end question for attendance?
My question for attendance would be, what is the range of an integer in a 16-bit, on a 16-bit microprocessor? How long, how small and how large can an integer properly be?